Alright, let's go through some of these points for the lesson on factorising algebraic terms. When you talk about the word factorising, really it's actually the opposite, or opposite means inverse, of expanding. Okay, so we talk about expanding as in removing the brackets. Eventually we're going to look at how factorising works to bring the brackets back in. But we'll worry about that later on. For the time being, let's just focus on this word, factorising and the word factor. So what is a factor? Okay, so a factor is a number that evenly divides another. Okay, so I'll give you an example. 3 is a factor of 12. How come? Because 3 can divide 12. You do 12 divided by 3 and it doesn't leave any remainder. So we call that dividing evenly. So we'll see that word here coming up later on, the word even or evenly. Okay, so think about any other factors for 12. So for example, I don't know, 1 can divide 12. So 1 technically is a factor. 2 can divide 12 as well. That leaves 6. It gives you 6 as an answer. 3 divides 12. It gives you 4. Obviously, the 12 divided by 3 gives you 4. 6 as well. 12 divided by 6 gives you 2. No remainders. Okay, so as long as it doesn't leave a remainder, okay, a factor, a number that can divide another number, it's called a factor then. Factors can also be found for algebraic terms, in other words, pronumerals. So, as an example, x is a factor of x squared y, because x can divide x squared y, since x can divide x squared y evenly. Okay, so this was what I was meant to say there. So, we'll have a look at an example where we do actually divide them. In fact, you know what? No, let's do that now. If I did x squared y, we're going to divide it by x. What do we get? Okay, so if you recall, I think one of the lessons before, okay, we looked at dividing. In fact, the lesson before was dividing algebraic terms. Okay, if you cross these off, you end up with xy, and there's no remainder. Okay, so x can divide x squared y. Let's have a look at an example. So let's find all the factors of ab squared. Okay, so that's an algebraic term. First of all, we'll look at the factors of the number. Okay, so the factors of 8. So the factors of 8 are 1, 2, 4, and 8. Each of these 4 numbers can divide the 8, and it does not leave any remainders. So 8 divided by 1 works. 8 divided by 2 works. 8 divided by 4 also works. 8 divided by 8, well, that goes once. 8 goes into 8 one time, and there's no remainder. What about the pronumerals or the variables? Okay, what can divide ab squared? Think of the factors that can divide that. So very similar to the last example. Okay, this example here. Okay, this example here. Okay, we have a can divide ab squared. B can divide ab squared. B squared can divide ab squared. AB can divide ab squared. There's actually quite a few, in fact. So then we can use combinations, and we can keep going and going actually. So we can combine the 2 and the a, we can combine the 2 and the b, 2 and the b squared. So each of these can be combined with any of these numbers, multiplied together, and they're also a factor. So really anything that can divide ab squared is a factor, and there's quite a few of them. Now let's move on to what we term the highest common factor, this HCF. Okay, and the HCF is also known as something else, and there's a calculator function we're going to learn shortly. I might have shown you this before, but okay, the HCF is also known as the GCD, which is the greatest common divisor. Let's see if I can fit it in there. Greatest common. Right, greatest common divisor means the same thing. Okay, so sometimes if you see GCD or HCF, as far as we're concerned, they're absolutely identical. They mean the same thing. Okay, so divisor, division. So this is where we talked about this division, something that divides something else. Right? That's where that comes into it. Okay, so highest common factor is the largest number that divides 2 or more terms evenly. Okay, or 2 or more numbers, doesn't matter, it can involve algebra as well. We're going to look at both examples shortly. Right, let's have a look at example number 2. So just looking at numbers only. Find the highest common factor of 18 and 24. So factors of 18, we're going to list them first. 1, 2, 3, 6, 9 and 18. So we're just looking at the numbers that can divide 18. What about the factors of 24? Factors of 24, there's actually a few more. We've got 1, 2, 3, 4, 6, 8, 12 and 24. All of those can divide 24. Which number is in common? And it's in the highest number that's in common between both of these. Okay, you can see here that I've underlined the 6. Okay, 6 can divide 18. 6 also divides 24. So this is what we call a common factor, because it's common, it's the same, right, for both of these numbers. So therefore, the highest common factor of 18 and 24 is 6. Now we're going to look at some examples involving algebraic terms. Okay. So the HCF can also be found for algebraic terms, as I mentioned earlier. Example number 3. Find the HCF of 5ab and 10b squared. Step number 1. We're going to find the HCF of the numbers only. So we have a 5 and a 10. Okay, so these two. HCF of 5 and 10. Think of a number that can divide 5 that also divides 10. If you want to list them out, you can. I think this one's fairly easy enough that we can come to the conclusion that 5 is the highest common factor. 5 can divide 5. 5 also divides 10. I don't think there's not going to be anything higher anyway, because 5 is the highest, is one of the numbers that's the highest it's going to be. The factor can't be higher than the number itself, especially when we're dealing with integers. HCF of AB and B squared. So now we're looking at the pronumeral part, right, the variables. Okay, so these two, AB and B squared. Okay, this one's probably a little bit easier in that what you got to find is try to find the symbols that are in common. This one's got an A, this one does not. So A is not a common factor. This one's got a B, this one's got a B squared. Now remember that B squared is just BB, can be expanded to BB, right? For example. So there's one B here, there's one B there, okay? So B would then be a common factor. Then what we do is that we multiply those together, all right? So the HCF of the numbers, HCF of the pronumerals. Therefore, HCF of 5AB and 10B squared is 5B. Okay, so 5 times B, this would be your highest common factor, or greatest common divisor, GCD. Now, example 4, I'm going to do things a little bit differently here. So I'm going to show you something you can do on your calculator if you want to find the highest common factor or the greatest common divisor very easily. Okay, and I haven't completed this answer yet, so this solution, right? So what we're going to do is we're going to learn a new function called the Gcd function. Okay, so just above the multiplication key there, you can see in red Gcd. I might just zoom this in a little bit, and hopefully you can see that a little bit clearer. Yep. Okay, so just above the multiplication key, if you press alpha, anything in red, you need to press alpha first. So just press alpha, a little A will come up, okay, and press the multiplication key, and then Gcd will come up on the screen. Then what we're going to do is we're going to put in these two numbers, 12 and 15. Okay, 12, shift, okay, closing bracket, and 15, and then close bracket. Okay, so the comma there is just above the bracket key there. Press equals, and we get 3. Okay. Okay, so the highest common factor, very, very handy function, that one. Very, very useful. So the highest common factor of 12 and 15. Okay, so GCD, 12 and 15, according to the calculator, is 3. Now we need to look at the pronumerals. Okay, so the GCD, okay, or the highest common factor. Sometimes I use GCD or HCF. I can use them interchangeably. It doesn't really matter which one. So HCF of that's x squared, y cubed, and xy squared. Think of the symbols that are in common. Okay, so what I might do is I might just write this out in full. X squared, it means xx. Y cubed means y. Xy squared, xy. We have 1x there, 1x there. Okay, so I might actually start underlining them. So x there, we have an x there. There's an x here, but there's no x in the other one, so we can't underline that one. We have a y here, a y there. We have a y here, we have a y there, okay? And that's it. So the HCF of x squared y cubed and xy squared, okay, is going to be x y squared, okay? Therefore, right, the highest common factor of 12x squared y cubed and 15xy squared is, we can now, we take that number there that we found before, 3, and then the pronumeral highest common factor that we found as well, and we combine them together by multiplication, and we have 3xy squared. Okay, so 3xy squared will divide 12x squared y cubed. 3xy squared can also divide 15xy squared. Okay, and so that's our solution.